So if you saw my last talk, this is the same picture. It is a cow flying through the sky. And if there is a metaphor for the cloud and development, I think this has to be it, because it is this like massive behemoth. Who comes up with this? It's amazing. Growing up with AWS, we're an HR company. If you also came to my last talk, you are familiar that I like alternate titles for talks. And growing up with AWS, the alternate title, I couldn't actually put this on the screen. It was, I wish I used Google Cloud, but that's, that's for another time. Namely, we're an HR software as a service company. We specialize in payroll, benefits, human capital management. So if you want to kind of connect to your employees, figure out goals, performance review, we're an all-in-one HR solution. We started in 2011, and we are on that phenomenal growth track of more customers, more features that we're developing, more complex infrastructure. We have more than 550 employees, and we're about 140 engineers. And like most high-growth companies, we are hiring, doing very interesting things with infrastructure we're going to talk about. So this is a story of growth. Namely, started in 2011. It was 4 people working together. And it was a Ruby on Rails app. You're banging out features, really working kind of hard, thinking about like, will this be successful? You're running on AWS, RDS, you have your single EC2 instance. There is no automation whatsoever. You're just copying and pasting stuff up, maybe some pre-Git ops, pre all of this wonderful things. And the next thing you know, you're on this journey, you are like growing, you have more customers, you have more engineers, they're adding more code. Things are getting a lot more complex. You, at one point, decide to write your own database. I don't know who signed off on that. Luckily, it did not make its way out into production. You adopt Kubernetes for microservices. You buy .NET SQL Server source code stack, and then you have this like wonderful dichotomy of Ruby on Rails engineers and C# developers trying to work together, which is absolutely fantastic. You decide to run Istio in production, which still gives me nightmares. Who signed off on that? It was me, and I cry myself to sleep every night. But it's actually working out pretty well for us, finally. But the most interesting growth story, I think, for us is our AWS Payments. Now, I didn't actually sign off with legal, so I couldn't put real numbers up here, but I feel like if you're a high-growth startup, like this is kind of fairly typical. Now, I didn't actually put bills because bills are not interesting. Payments are more interesting. And if you notice, there's this gap here, and I'm like, what happened there? And it turns out, like in true startup land story, from 2012 to 2016, we were paying on somebody's credit card. And then they were like, you can't actually do that anymore. And then they didn't figure out what to do for 3 months. Now, like, luckily we kept running, but yeah, this was very interesting. And then it's like, you know, that chaos story, right? But no, it's like, this is actually like very typical, because it's like you're working really hard, you're doing something, you have more engineers, you're working, you don't really kind of care, you like have an oops, oh my God, what is going on moment. You try to stabilize, and then you like hit more growth, and then you kind of come back and you try to readjust. And at least here, like this is because we're purchasing reserved instances, so these aren't like amortized costs. That would have been much more interesting. But like, you know, the funny thing that I have is like, you know, as you're growing, you're building your product, but you also can't let your infrastructure get away from you, right? And the interesting conversations that I have with like our CTO is, do we stop what we're doing and deal with this, or like how much burn can you actually have? And I think as we grow and we get smarter, we learn a lot more, we leverage a lot more, and that kind of helps us guide decisions. And you know, to kind of put things in perspective as well, like where we're at right now is about 3.5% of our ARR, which you know is like rather high for me, but it's not like scary. Like our CFO hates it, but our CTO doesn't, and I think that that's like a good heat wave of how well we're doing. You know, and then also like from 2012 to 2018, like Amazon has also had an explosion of like new products and new growth. So the options that we had available in 2011 when we started, and even when we made major infrastructure changes in 2015 and 2016, are like quite different, right? Like if we had Lambda back in the day, would we have used it? And I'll talk about the decisions we made, like why we made them, and then how you as an organization, and specifically namely, can kind of adopt to a growing and maturing infrastructure landscape, and then try to like leverage technology to help you develop quickly and then also manage costs. So what does like infrastructure look like? I think that this is kind of how we view the entire world. So we have environment management. That's kind of like how are we managing our infrastructure. We use AWS, obviously, and then try to leverage that as much as possible. We have our runtime, which is how are we actually running our code? And the choices we made there are Kubernetes, Docker, app servers. You have configuration, you have continuous integration, continuous delivery. How do I get my code out to production? And then how are you operating this, right? And then across the entire stack, you have observability. How do you know, like, are things working? And then you have security, and how do you like know that things are secure and then you have the right access controls in place. And in terms of like choices that we made or that we've evolved to, this is the landscape that we're at, right? So we do heavily use Terraform for managing what our environments look like in our servers for like repeated code that we just learned. You know, AWS is our platform of choice. We use Kubernetes plus Istio as our runtime in terms of thinking about kind of containers and deploying code and how are we doing routing and interesting things. Kubernetes and Octopus are our configuration tool. We use config maps and secrets pretty heavily. Jenkins, it is just so simple and it can do so much. And I think as engineers, if you're like newer or you want to think about like up-leveling, there are 3 things that I think that you should know. Git, regex, and Jenkins. Because if you master those 3 things, you are effectively like unstoppable for continuing to put out code to production, and you will solve any problem that any other engineer in your organization has as to like, how do I actually release this thing? Spinnaker, kubectl, Kubernetes, those are our control mechanisms for thinking about like how do we manage what versions are running. And then on the observability side, there's no like one-stop shop for this. So we have SignalFX, is our metrics and monitoring tool, and we've actually been using that for tracing as well. Logs.io is our hosted Elk stack, New Relic for APM, and then a whole plethora of access controls that we've been leveraging in terms of identity access management, RBAC security. We've been integrating with IAM a lot more in our Kubernetes cluster that I'll talk about in a bit. And then obviously VPN and secrets for actually accessing our production servers. And the thing that I've also embraced is in terms of these choices, I just feel like there's never a right answer, right? Like you can go with Kubernetes, you can go with EKS, you can go with serverless, you can go with API Gateway, you can run on Docker Swarm, but like it's never going to be a right answer, and I feel like that there's a huge liberating experience that I had when you've just embraced the fact that you can never be right. There's only varying degrees of wrong, and I think that that's helps us think about the now and how do we develop and leverage what we have so that we can move forward, and then realize that things change, right? We experiment, we learn, we decide, and then we repeat this process. And so even though that things like EKS weren't available 2 years ago, they're available now, and can we use our past experience? Do we have that automation in place to think that we can move to it? And then maybe in 2 years from now, we actually are going to go all in on serverless, or we're going to adapt it, or we're going to feel like that's the right choice. So thinking about the here and now and thinking about automation and thinking about really getting that code to production is the most important aspect. And then as you go on, you find like the most painful point that you have to deal with, and then you focus on that, you improve that, and then you move on to the next thing. It's that classic agile methodology and agile way. So our namely infrastructure, the way we're at now, is we're only in a single region. I do want to be multi-region. That's kind of one of our wish list items. But for now, we only exist in AWS Virginia. And one of the things that we've adopted and leveraged are AWS accounts. So we have a portal account that we manage all of our users in. That portal account has absolutely nothing in it, but it's linked to all of our other accounts that have its own VPC or virtual private cloud, right? So production is its own AWS account. It has a special set of users who can access that. It has its own VPC. We do the same thing for our staging environment. We have a special one for our IT and operations. Sometimes we run Kubernetes in these. We also work with a lot of different cloud vendors, and we give our cloud vendors their own AWS accounts. So that's how we run Kafka with Confluent. We actually have Confluent managed servers, but we own the account, we own the VPC, and then we have a permission-based mechanisms to talk to it. And this is like one of the first infrastructure aspects that we really started to leverage in terms of evolving our topology. So what does an environment look like, right? And I think that one of the interesting things, especially with managing costs that I'm going to dig into, is like how did we learn about these things and what really bad mistakes did we make that we have to fix later on? So we have Kubernetes. That's kind of like the heart of a lot of our infrastructure. We usually run with 15 workers. There's 3 masters and 5 etcd nodes. We have public ELBs that allow traffic from the outside to come into our VPC. You need an internet gateway to send external traffic. We have our own EC2 servers for a variety of things. We have jump boxes or Bastion hosts for special use cases. And then the topology is a whole plethora of like your AWS products. So we have like a lot of Elastic Cache, way too much, completely over provisioned. It's amazing. We have a bunch of RDS because you just need a lot of databases. We are moving to Aurora, so we're starting to leverage that a lot more. Again, like a bunch of S3 for storing things like backups and files and images, CloudFront for distribution. But this is like generally it, and I think that when you start off with 4 or 5 engineers and a simple Ruby on Rails, like this is much simpler. When you have 140 engineers and they're all trying to push out code, this becomes kind of crazy. And then what are the cost controls that you allow, and what are the access controls that you allow for people to do different work in? So as a concrete example of like really weird things, we were spending $17,000 a month on our NAT Gateway, which was like amazing to me, not necessarily for the price, but like we were sending out 380 terabytes a month of information on a site that gets like, let's say, 100 QPS. I'm like, what is going on here? How are we sending 380 terabytes a month on egress traffic? Like somebody has to be running like a BitTorrent host. And there's this thing called VPC endpoints, right? Which if you don't know about it, I highly suggest you learn it. What a VPC endpoint is that it allows you to talk to, let's say, an S3 bucket on your VPC. So I can say that if I have to store a file, like a Docker container image from my CI system in S3, I can do that with a 10/8 address, and I don't have to go out to my NAT gateway, and I don't have to send 380 terabytes of data on the public internet to store it in S3. And I was like super excited because it's like, yes, we like save so much money. We're down to $1,500 a month in NAT with 33 terabytes. We probably have like also 30 terabytes that we can still go here. But like the only thing that made me I felt really good about this, but then the only thing that made me feel like even worse was that we were spending so much money for so long, and it was just a config change because we didn't know any better. And that's the price of knowledge. Kubernetes, love Kubernetes. We were running our own Kubernetes clusters with Kube AWS. That's an automation tool. We tried Kops. Kops had a lot of idiosyncrasies when we tried it, so we went back to Kube AWS. Essentially, you have 5 etcd servers. That's where state is stored. You have these master nodes that do a lot of the work, and then you have these workers where stuff runs. And then Amazon comes out with this wonderful thing called EKS. It's basically the same thing, except you only have to worry about workers, and just like that, you cut your server load almost in half. And the interesting thing about EKS, and this kind of goes into like leveraging the platform, because I've kind of had like this interesting revelation where you want to be cloud agnostic, like Kubernetes is great to be cloud agnostic, but I think that that's actually a little bit wrong, where you want to leverage it a little bit more, right? You really want to understand that platform that's available to you and how you can leverage it. And when I say better networking, if you're not familiar with Kubernetes, it essentially has this plug-in model where you can plug in the networking infrastructure. So you as a provider, like let's say Amazon, can describe how Kubernetes should manage networking. And EKS did something really cool where they mapped their elastic network interfaces, these like virtual network interfaces that plug directly into their networking fabric and their VPCs into Kubernetes pods, right? So each pod on a host has its own elastic network interface with its own IP that's like tied into their Nitro system or whatever it's called. But from a tangible performance benefit, just by this one change, not only do we not have to run a lot of other servers, but we saw about like a 10% performance increase in our inter-service traffic. So this is a graph that we have, a week-over-week graph. And the only change, this is essentially our synthetic load generator that we're always using to like monitor our services up. It's basically making a request from one service to another service, and it's tracking the median times and the P95 times. And this is a week-over-week graph. So the purple line was like before the change, and then the gray line was exact same thing, same version of both of these apps, Just one was running on our old Kubernetes infrastructure, and then now we're running on our new Kubernetes infrastructure. And also, just like same EC2 instance types, right? We were use R5s, still R5s like other R5s. This is just an EKS change, and we're getting like a much more improved P95 times of like almost a millisecond, and then about a half a millisecond on our median times. And that's just like leveraging the platform and leveraging the infrastructure, and then knowing that it's kind of there, but also like what do you get for free using these tools, and that's just like phenomenal for us. So I'm going to hand it off to my colleague Riyad, who's our staff database engineer, and he's going to talk a lot about the performance optimizations that we've made across the board with our storage systems.
My name is Riyad Amari. I joined Namely 3 months ago. I'm staff engineer database, so what they call the new DBA. So we just here, I just want to show you how you have to think outside the box. So it's not the old way how you have a DB, you have to go through the SQL, and you have to see if there is a problem, not a problem. So anyway, I faced up with this problem with data warehouse. We have an EC2 running, the SQL server, terabytes of data. We have everything set up correctly, tuned well, query are running perfect on staging, on the dev environment. But here we see, as you can see here, in the middle of the day, we faced the I/O concurrency issue, and we had a lot of issue with latency, and customer cannot get their analytic on right up to the second. So after a while, we started to go to CloudWatch. Hey, what's the problem? We saw together that there is a problem in read I/O and write I/O. So why we do that? So after a couple of research, so we switched the EBS, like you see, you switched the EBS from GB2, which is a regular SSD, to provisioned IOPS. So as you can see, with no downtime, as you can see, everything is flat. After that, so you solve your problem and you leverage Amazon services without the need on the old way. Hey, maybe I need to change this one, and then I build in the middle of the day query. I need to test them. So sometimes you need to think outside the box. So another example, which is we have a multiple environment like you do. We have a test. We have a dev environment. So you need the fresh data nightly to be pushed to other environments so that you can have accurate information while you are building, while you are developing. So sometimes, like you are thinking, hey, let me have a master, nice master database as a RDS, and okay, I need read replica, so I don't need to pay that much money in read replica. Let me put something like simple, like T2 medium with the master. So at the end, you are comparing. You have like two things, like master as Ferrari and the read replica as a Toyota Pyrus. I hope there's nobody from Toyota. So anyway, so one of the things, as you can see here, so when you push a couple of hundreds of gig of data during the night, as you can see, look at the latency. Sometimes the latency between the master and the read replica takes 3 to 4 hours so that the read replica can synchronize with the master. And it will affect all other systems, all our other pipelines that we have during the night, so that the team. So we have offshore team, of course. So we have to have the system ready by 3 a.m. So we cannot afford to have the read replica will be ready at 6 or 5 a.m. So again, so leveraging the IOPS also the same. So we pass from 3 hours replication lag to almost none, less than 5 minutes. So sometimes, yes, it's true, you need to save money, but sometimes you need to spend. Another thing that we try to do, so which is DB encryption. So as you know, so New York State requirement for the encryption at rest went into effect, I think September 2018 or something like that. So we don't want to have KMS keys or everywhere. So we have a master account, like Mike said. So we have a master KMS, and it's distributed across account. So, and with that, we encrypt all our EC2s and RDS instances, and we are in process to make sure that we encrypt all the data in transit with all these KMS. Elastic Cache, we are a heavy user of Redis. We have plus 50 plus instances, millions of keys. One of the things also we try to do, as I put it in this slide, so we try to use the sharding with data partitioning, because if you take Redis as is, it means an instance with the read replica. Actually, you are paying for the read replica just sitting there. The instance, it's good, you are using it for read-write, but the read replica is just sitting there. It's a failover. You are not using it. So, for example, for us, we have a couple of instances. They have a couple of million, but your swap start to use. Or when you use a swap, no more cache. So it means you are using swap. So that's why we are transitioning from Redis instances to Redis cluster. So we will have better sharding. You can use the cluster entirely, so your read-write across the board. And the last thing, of course, we use Terraform with all what we showed you, especially with the database. Everything has to be done it has to be automated. So we are building our DR site. So whatever we provision as IOPS or RDS, it has to be automatically done in another region.
In terms of like leveraging AWS and thinking about it, I think one of the most interesting things that we in the industry talk about a lot is like Lambda, right? And I think that we think about Lambda in terms of the API gateway and read-write requests, but Lambda I think is pretty interesting in the sense that it's giving us new opportunity to think about things like scheduled jobs and like these one-off tasks. And when you kind of combine it, and I think that this is the most interesting aspect of like AWS, when you combine it with all of the different mechanisms that you can invoke and call Lambda functions, it's a very powerful tool for automation, and especially on the DevOps front. So this is one of the first and main use cases of Lambda, where we were automating our nightly backup process with Lambda. Previously, these were like very obscure and like hard to deal with cron jobs. This Lambda function was actually like written in Go, which allowed us to get a lot of the type safety and testability that we wanted. And it's triggered by a CloudWatch event that will invoke the Lambda function at a particular time, kick off this process. And this is something that we are leveraging a lot more in our infrastructure to easily manage and understand a lot of the automation that we want to build, especially in moving data from one account to another. And then it's baked into the fabric of IAM and the role-based permission system that we want to achieve. Reserved instances, a lot of this can kind of be like a shot in the dark, right? Like, what instance size do I need? Let me just use like an M5 medium because that thinks that makes sense without actually having to do that due diligence. And as we evolve our engineering organization, and certainly as we leverage observability a lot more, instance sizing is the thing that comes to mind the most. Now, we just happen to use EKS, so we get a little bit more dynamic nature in terms of the CPU resources that we need, but across the board, whether it's how are we configuring node pools on EKS, or how are we dealing with RDS and Elastic Cache sizing, we're starting to think a lot more and be more disciplined as an engineering to ensure that we're starting small, but what we need, and then we have that automation and we have that way of growing into our instances as we see fit. One of the key elements, I think, too, is understanding what your infrastructure looks like. So we're big fans of SignalFX. And then one of the things that we did as we leverage this tool is make sure that we have proper tag data on all of our instances so that we could attribute what environment our EC2 nodes are, what usage we've slated, potentially what team that we've built things like RDS databases for, so that we have some amount of ownership and understanding of like what we're doing. And the thing that I love about SignalFX, and there's some other observability tools out there, is that it allows this like quick and easy multidimensional analysis. So in this particular example, I'm grouping by AWS the namely env tag that we apply to all of our instances. I can filter on specific instances. I can understand, is it CPU utilization that's an issue? Is it memory bound? And then as you can see, like even though that we're a little bit yellow in production, I think that that's actually okay because it means that we're utilizing and we've sized our instances appropriately. You know, our lower environments are definitely over provisioned. You know, that's kind of okay. It's something that we want to deal with. But, you know, a little bit of yellow or even on the red side, I think is that we're actually properly optimized. And as we mature to really think about tuning our auto-scaling groups, and one of the great things that Kubernetes now offers on AWS is this notion of vertical and horizontal pod auto-scaling. We can really like tune and optimize around this number. And help lower our overall costs, but just make sure that we're not necessarily overpaying for what we don't need and progressing our infrastructure ability. So as I kind of like wrap up, when we think about 2019, things that we're very curious about is the container evolution strategy for AWS. So we heard Fargate mentioned previously. Fargate is a way of running kind of containers without having to worry about the underlying server sizing. So with Fargate, you say, I want to run this Docker container, give it 2 CPUs and 200 megabytes of memory, or 2 gigs of memory, and then you're just provisioning, you're just paying for that. And one of the things that they do have planned is the ability to effectively use the Kubernetes API to launch Fargate instances. And I think that that's great, and I think that also shows a little bit the power of like the Kubernetes ecosystem and the API that Kubernetes provides, which is we don't necessarily need to worry about nodes anymore in terms of trying to map containers onto nodes and should I use R5 extra larges or should I use high compute, is that we can do that at the pod level and then have Fargate manage that for us, but not necessarily get quote unquote locked in to the whole Fargate API, right? And it's like we may want to get locked into AWS, that's kind of inevitable, but we can at least use these open source APIs and these open source standards to make our automation and to leverage the whole open source ecosystem around Kubernetes a little bit easier. Transit Gateway is something that's very interesting in terms of managing VPCs. So whereas you would have to worry a lot about routing tables and IP address rules and how am I stitching everything together, Transit Gateway was released at the latest AWS reInvent. And that's kind of a better way of, I think, building out the automation of the platform to make VPC traffic and inter-VPC traffic work a little bit better. Aurora Postgres. So we're big fans of Aurora. We use Postgres. Unfortunately, Aurora Postgres is always like lagging behind Aurora MySQL. So if you're choosing between these two, as much as you may love Postgres, just go with Aurora MySQL. But that's kind of coming along, and I think that moving to a multi-region strategy, it already is happening with Aurora MySQL. When that goes with Postgres, I think we're going to have a lot more opportunities for dealing with kind of distributed state management across regions and what that means for how we build and develop our apps. Lambda is something that I've always been somewhat skeptical about. It does have a great amount of advantages, but there's an element that you have to learn for it in terms of how am I dealing with IAM permissioning, how am I dealing with kind of config management, where we've matured our Kubernetes ecosystem so much, that's kind of like our easy default. That doesn't mean that there isn't a benefit for Lambda, but introducing that into our ecosystem in a way that makes sense can be very beneficial. EC2 optimizations, I think that there's always great stuff happening on the EC2 front. And I think that this is one element where using something like Terraform becomes very important, where can I easily create my infrastructure on new instance types? Can I easily do A/B comparisons to know, is it worth it for me to move to a next generation class, or can I experiment with different instance sizes without having to click a lot of elements on a UI? That may be okay, a 5-person engineering organization or even a 10-person engineering organization, but when you're at 140 engineers, automation and infrastructure as code is absolutely instrumental in the success for moving at speed and moving safely. And then finally, better account management. I think where we can map roles, and I think that the whole IAM ecosystem is like one of those very complex elements that if you can spend some time devoting to it when you're ready as an organization, you can really unlock a lot of the power of AWS and a lot of the power of an engineer being able to do things quickly, but also do it safely and not do things like leaking out kind of privileged information or making sure that we have the right restrictions in place and audit capabilities in place for who's accessing what. So that's it. I ended this with my last talk, and I also think that it's very important, is like everything that we do is an investment. We want to return on that investment, and we must build up on what we've done. And so if you're spinning your wheels, you're trying different things, but you're not necessarily moving forward, that can be damaging. And I also think, again, that you don't have to worry about making the right choice at the time. I think that what makes or breaks kind of organizations, especially ones that are growing fast, is do you have a mechanism to evolve when you need to evolve, right? If you've locked yourself into something too much and you're not willing to like take a breather or reevaluate, is this worth my time and what is an investment that I need to make in something else, or have an evaluation process, that's where I think that you could be left with something that becomes unmanageable. And I think that the thing that I'm most proud of when I think about namely infrastructure and what we've done is we've embraced this like refactoring of our infrastructure the same way that we refactor our code, right? We're not stuck into any particular technology or way of doing things. We can evolve Lambda and introduce that into our ecosystem. We can move from managing our own Kubernetes to EKS. We can introduce Istio as a layer on top of our infrastructure to help us solve some problems. And that's it. Thank you very much.